this video, we're going to look at odd functions on the interval from negative a to a. Odd functions mean that they are symmetric about the origin. So some examples of some functions which are symmetric about the origin are x cubed and sine. Okay. Now you're probably noticing again that x cubed is odd. Wow. Yes, that's kind of why they came up with that name, but you also need to be careful because there are hidden ones. By the way, tangent's also an odd function. So again, what I suggest to students is if you're unsure if it's odd or even or no symmetry, just plug it into Desmos and graph it. Okay, so what we're interested in doing is what happens if I want to find the integral from, let's say, negative 2 to 2 of x cubed. Okay, so we can just use our fundamental theorem of calculus part to integrate this, plug in negative 2, but I'm going to go ahead and let you in on a secret. It's going to equal 0. So you're going to go through all that work, all that arithmetic, and you're going to get 0, and then you're going to think, oh my God, did I screw up? Did I mess up the arithmetic? This shouldn't be 0. Well, let's graph it and see if it should be 0. Oh, that's a great y-axis there, but that's okay. It'll serve its purpose. All right, so there is x cubed. So let's go to 2, and let's go to negative 2. You tell me, are we going to get a net area of 0? What do you think? Is the area below equal to the area above? Yeah. Okay, so in this case, this will help save you some time if you notice ahead of time that that's what's going on, that you have an odd function on a symmetric interval from negative 2 to 2, negative 3 to 3, negative 1 to 1, negative 25 to 25. That area is always going to cancel, always, if you are odd. And that's because you're symmetric about the origin. So you're symmetric about these alternating corners, or the other way as well. Okay, so let's look at sine. So for example, if I was asked to integrate from negative pi to pi of sine x dx, turns out that this should equal 0, but let's see if that's true. Let's draw a picture. Yep, that looks true to me. That bump below matches this bump above. I get 0. All right, so this seems pretty easy, right? Okay, well, be careful. What happens, so let me show you a pitfall that some students make. So give me 1 minute. All right, so let's look at this problem right here, which is the integral of x cubed plus x squared dx from negative 1 to 1. Okay, so what happens is that some students will tell me that this integral equals 0. And I'm sorry, that's not true. And the reason why students will say it's 0 is because they'll say, oh, the degree is 3, it's odd, it's going to 0 out. So what happens is actually part of it zeroes out. So what we know is that we can break up integrals into parts. There we go. So what'll happen is that I agree that this portion would 0 out because it's from negative 1 to 1 of an odd. So this will go to 0. However, this one is going to survive. You would still have some things. How many things? Well, if you wanted to, you could do, because this is an even, you could do the integral from 0 to 1, double it, of x squared dx. Okay, so that's the answer to this is what would be the answer to the whole thing. So I would just caution you, if you are excited about using this rule, you can use it, but it's not going to, the whole thing won't equal 0. If you have a sum of parts that are odd and even, the odd parts will 0 out on the symmetric interval, but the even ones will still survive. So be careful. All right, so good luck as you use these shortcuts.